All right, welcome in everyone. So happy week 9, happy Monday. We are 4 weeks left in this course, including this week, I suppose. So 4 weeks left. As a reminder, after today's class, I'm going to drop the last 3 assignments. I was hoping I was going to leave it kind of up until now so that everyone could catch up. If you haven't, I guess this is the call to catch up. Last 3 assignments will be posted after today's class. There's 3 to 4 more weeks left. I don't expect you guys to finish I expect you to finish it at some point, but the tuples and dictionaries assignment, maybe that one could be, that one's going to be at the last assignment, which is what we're going to go over tuples today. But when you see the tuples and dictionary assignment, don't freak out so much about it. If you do go into the Python, if you do finish the chapter module 4, then feel free to start it. But we're going to, there's 2 assignments that should be good for you guys to do, which will be on list and on functions. The list assignment, the cool thing about the list assignment is, if I go pull it up, if you look on my screen, this is going to be the assignment you're assigned. The assignment you're assigned. It's a good one. It's going to be actually from the code lab. So public, it's not from me. It's from the actual lab. And then I ask you to do some small things to it, and then do some more alterations. This one again. The hope with these assignments is that they should be fast. The last loops assignment was a little bit lengthier, I would say, but still not as lengthy as you would think. This one should be a little bit less work. And then it says take the module 3 quiz, just so that you guys can, if you are doing the assignment, it reminds you to do this. In terms of the class finishing right now, I believe I have one student who actually has submitted the last assignment 4, but that's okay because I think I gave it a little bit, like I think midweek last week. But make sure to do assignment 4. But in terms of this class's finishing, I think I have only 3 students who are on track to finish the class and get the voucher from me. That's on track at the moment, like they're staying with it. I have about 4 or 5 more students who are fringe students who are close to being finished, I think, or can catch up easily. So if you are one of those students, take this week and the weekend, and again, feel free to email me. I keep saying that a bunch, is that email me and I will help. I will, I'll set up a meeting with you, whatever it may be. And we could crack this out, and it shouldn't take you too long to catch up. I think it's only really, I think at the current moment, there's 8 things I ask you to do, which is, no, my bad, 7 things. The module 1 test, which most have already finished. Module 2 and module 3 tests, which most haven't finished, but I have gone over module 2 test pretty lengthy in one of the videos. Might be week 4, week 5 videos. Actually, I can go see which one it was. When do I go over module 2 test? In week 5, I believe it's the module 2 test I go over with you guys. I actually give you like a good amount of it. The module 2 test also, you have unlimited tries, so don't be afraid to fail it. It's you just have unlimited takes, and that's it. But I go over module 2 tests. So if you are having problems with taking it, I have it. And then week 7, I believe, I do have the module 3 test. I do a little bit less work on that one compared to the one before, but again, you have unlimited tries. So only module 2, module 3 tests that I assume most people need to catch up on. And then the assignments, most students did assignment 1. If you haven't, feel free to do it. It's pretty simple. It should take you like 5 minutes at this point, maybe less. Assignment 2 and 3 and 4, 2 and 3 assignment 2 should be very fast. Assignment 3 is a little bit lengthier, but still pretty fast. And assignment 4, that one's gonna be the lengthiest, I think. But again, if you aren't caught up yet, you still have plenty of time, but I want you to do it this week. Catch up now, because if you are able to catch up now, you don't have to worry. You can do assignment by assignment, one assignment a week, and you're done for the class. And then I can give you the free voucher to take the exam, the certification exam at the end of the quarter, or at the end of this class is over. So if you are a little bit on the fringe right now or behind, perfectly fine. Email me. We can do something to work together. Or if you are confident enough to do it by yourself, go ahead and do that. It shouldn't take you too long, I believe. Maybe a good day would probably suffice if you've been watching the videos, which I assume I know most of you have been or in the class. And then you have 3 to 4 more weeks left of this course, 4 weeks including today, so a month left. So good amount of time to get by then. I want you to finish in 3 weeks because that 4th week is kind of that's a gap week of probably the certification exam study time. So 3 weeks, I want you guys to finish all the stuff. But today we're going to go over, and then this module 3 quiz. Today we're going to go over a little bit of the continuation of what we did last week. So I know that there was some issues with changing over and all that stuff, but I noticed people who didn't were a little bit later to the last one are here, which is good. We'll go over a little bit over functions again. And if you're behind, email me or watch the videos again. But today we'll go over a little bit of just a summary of functions. So as you guys remember, functions are kind of this black box where it's like, you don't know what's in it. Well, you could either know what's in it or not what's in it, but what happens is you send it something and it'll print it out, or it will do some sort of action inside of the function, and then it'll return back some sort of value that needs to be done. So in here, this is not really a good test of functions, but kind of building off the last one. Are we taking the certification together or individually? You'll be taking the certification individually. It's going to be, I believe, again, I don't say this with extreme confidence, but I'm pretty certain it's going to be individual certification exam where you take it by yourself. And it's based off of this NetAcad. So if you are in the class doing the NetAcad and then hopefully doing really good on my assignments, or just doing the assignments, really, I know you guys, anyone that did make mistakes on the assignments were fairly small and like just nitpicky on my end. But again, if that doesn't matter, but in terms of this individual, it is going to be individual, I'm pretty certain. But again, if you're paying attention to the class and then taking the NetAcad videos, the thing, it should be pretty straightforward. That's what we're kind of building you up for. And then here, just kind of a scoping test. What we have here is, so scopes, I didn't get really too into detail last week, which is a scope is kind of the area that a variable lives, is a part of a code where the name is properly recognizable. That's their functionality of it, right? So x equals 123. So if we print this out, right, we're going to say scope test print x. What's going to happen? We're going to get an error because this print x right here has no idea what's going on. Even though there's this x equals 123 and it's done before, it's not done in the correct scope. So I could do anything I want to do here, a equals b, or I can't do that. A equals 4, b equals c, right? This is all in the scope of this function. Once we leave this function, it won't exist here. Unless, and this is kind of what we talked about a little bit last week, unless we make this a global. If I make this a global x, and then let's say x equals 123, now let's see what happens. Now we get 123. I need to refresh it because this NetAcad console does not, it like keeps it over. 123. So now we printed x, and let's say we print a, right? The thing that we did before, we're going to get 123. It prints out the 123 because we made this global. Global means now that all scopes can see it. Kind of, if you're kind of picking up, scope is going to be small what you see, and then global is going to be the overarching thing you see. And then in terms of this, 123, and then print a, again, we didn't make this, it's not global, so it has no idea what's going on here. Now, if I make this global a, this now will work, 123 and 4. So it does work once I make it global. Now what I could do is do this. This is another scope test, which would be, we could make it a equals, let's say a equals 100. And then let's print a here. Oh, I need to refresh this, always forget that. So here we have a equals 100, right? We go into scope test, we print out a here, right? Because let's follow it like we would in like this is called code tracing. This is how you debug or whenever you have problems. It's again simple stuff, which is you're going to start from here, right? This is where we define it. Because we're defining it, we're not calling the function. This is just the definition of it. So here we called scope test. It has nothing inside of it. And this definition of it is just, we're creating a definition. We're not calling it, we're not using it. So that's why we're going to start from a equals 100, scope test. So now we're calling it. So now it's going to actually go in here and actually do the functions or do the actions inside the function. So global x equals 123. Okay, so we made this a global variable. And then what's going to happen is we're going to go to a equals 4, print a. Cool, we did a equals 4, print a. That makes sense. We've been doing that all class. B equals c, not even using that. Then we're going to go back to here, right? Because we just called it. Now we're going to go back to where we just called. We're going to print x now. Now when we print x, we get 123, right? That global variable. And then when we print a, now we have it printing. It doesn't crash on us anymore, but it prints a equals 100, which is the reason for that being that a is equal to 4 is in that scope. It's not in this scope. This scope has a equal 100 here. Now, if we want to be, let's get funky here. Let's say we make global a. Now what's going to happen? Is it going to be 4 now? Is it going to be still 100? Or what's going to happen? And the answer is 4, 123. And now when we made this global, it changes all the values outside of it to 4. So that's a little bit of scope. Scope is kind of, it's a common phrase in computer science. It's when you're working with a function with similar, you can have similar names, right? I have a here, yet somehow this global a, once I make this global, this a will print this a. But if I don't, oops, there. Oops, let's refresh and run it again. So now we have 4, oh, I changed the value to 122, but then here a is now back to 100 because it's not global. Because in this scope, a is 4. And again, if we get rid of the global here, global won't, the global, because it's not global, this x equals 122, print x doesn't exist. Hopefully that makes a little bit of sense on the scopes of that and how globals work. And if you look more into your functionality, there's things like this, right? This kind of works exactly what we're talking about. We have our function definition here. Do I know this variable? Variable equals 1, my function print var. Do you know that variable 1? We call the function. It goes, yeah, I know that function because we called it before we defined it before the function started. So the answer is, yeah, I know that variable exists. Print variable, done. Then they have this thing where they say, let's make a small change to the code. Let's just copy this, paste it there. And I hate that I always have to refresh it. Do I know that variable? So now we have variable equals 1. Again, we define it first, right? But because we defined it doesn't mean we call it first. We're going to start from here. This is where our code starts. This is, our Python will read this and go, okay, I know what this, I need to, like, you have to define it first so that Python knows, okay, I know what the function is. And then when you do it afterwards, this is kind of the area where you say, okay, this is where I'm going to start from. So you define and then start, right? You can't know what you're doing without defining it first. It's kind of like, because if I called my function, how would my function know what my function is without a define? So think of this define has to show up before we actually call it. So here we're going to start from variable equals 1, right? So we're going to have 1 variable. Now we're going to call the my function. So now we're going to go all the way up to here, right? To this function call. Then we're going to say variable equals 2 now. So here, just like how we talked about before, variable is going to equal 2. And then when I escape, because this is only in this function scope, let me put this here, only exists in this function's scope. When I go back to here, it's going to go back to equaling 1 again, which is why this says 1 right here, and then this says 2. So that's scoping in a sense. And then there's more examples that they give you. I'll let you guys do that yourselves. And if I go back, we're gonna have one more function. I don't think I actually want to do any of these ones. So we're gonna go create a new idle. Let's go here. Oops, I just want to open up a new, let me do it here. File, new file. Okay, perfect. I had to do it on another monitor. So here we're on our new idle file, like how we've been doing all quarter or all class. And this is one function that I didn't get to go over last time, which is recursion. Right? Recursion is just a function calling itself. That is recursion. It's a strange topic, I'll say this, but it is useful. It's very useful when you go down. So one thing is, just a quick track. How many of you guys know what a Fibonacci sequence is?
I do.
You know Fibonacci sequence? Okay. So I'll go give a brief idea of what Fibonacci sequence is. Let me go and create a new window. So here we have, I'll just go and give Fibonacci sequence. We'll look this up together. So this is one of the most common things you learn in computer science. Like every time you learn recursion, this is the first way of doing it. Now, the way I'm going to teach you it, the thing about it being recursive, this is a way that people do Fibonacci's recursively, but it's not very efficient, but I'm still going to teach it to you. But this is the most, or like, this is your hello world. Anytime you learn recursion, they do Fibonacci sequence. And all the Fibonacci sequence is it's this number that keeps adding the old number up, right? So we start off with, technically you have a 0 here. It could start off with 0, f of 0, 0, or f of 0 is 1. So you're gonna start with 1 and 0 here, but in this case, they said, you know what, we don't need it. Doesn't make a difference whether you count or not. So 1 plus 1 equals 2. 2 plus 1 equals 3. 3 plus 2 equals 5. 5 plus 3 is 8. 8 plus 5 is 13. 13 plus 8 is 21. It's literally taking the last two things you created to create the new item in the list. That's the sequence. The next sequence list item. So right now, if I want to see this dot, 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 what's going to come after this is going to be 377 plus 233. That's going to be what this number is right here. That's all the Fibonacci sequence is. Take the last two numbers and add a new one. It's really cool and occurs in pine cones and pineapples. Yep, it's this, I forgot what it's called, the golden ratio or something like that, but it's this, I think there's a meme about it too I've been seeing on Twitter where it's like everything always revolves around this. I think the Will Smith Oscar slap, if anyone has seen that, they even they calculated the trajectory of his smack and they said it makes this motion. And so it's a really funny thing that they do, like, and where's the pine cones and pineapples? You can see it everywhere. But this is the Fibonacci sequence. And so if we're going to actually create the function here, right? We always create the function first. We're just defining it. We're not going to actually call it until we actually like make the call. So right now we're going to say define Fibonacci, and we're going to say put a colon here, right? Just like how you do as usual, define fib here. And then because we want to give it an argument, right? We want to give it an argument of, or a parameter, I think is what Neticat calls it. Parameter, argument, same thing. So in here, we're going to give it a number, right? This n is, let's just give it a number. Yeah, let's call it num, right? So we're going to give it a number. This number is going to be our up to. I'll put this comment here. Say Fibonacci. This is how you should write your commenting. This is a good way of doing it, is function to find Fibonacci number, to find Fibonacci number of the number given. Maybe this isn't the greatest words I put in together, but I'm trying to think of on the fly and I'm not doing such a great job. So here, the classic Fibonacci sequence is this is like you have and this is your base case, they call it, right? If n is less than 1, right? Oh, oops, if num is less than 1, right? This is going to be our return. And here, this is something cool. You can say return none. We don't return anything. You could also make it return 0, but we're going to say return none or return 1, I think. No, return 0. If it's whatever we want to return, our base case of a Fibonacci sequence, I should pull up that photo again, put it on the side right here. Yep. Is that whenever we return the base case of it, we're kind of working like it's a little bit confusing at first when I keep trying to explain it, but it's that if you have your base case where if you have your numbers less than 1, we return none. And it's better if I just actually finish it off and then show you what happens. Let's try that. Number is less than 3, right? So this means if this is going to be 0 and this is going to be 1 or 2, right? Because if the number is less than 1, which is going to be 0, if our number is less than 3, 1 or 2, we're going to return 1. And then our end is we're going to return fib, and this is the recursion part, right? I'm calling itself now. Fibonacci of num minus 1. And if you don't get it at first, I 100% understand. It took me a while to understand this as well. So Fibonacci num minus 1 plus Fibonacci number minus 2. And so the idea is when I run this, and I'm going to put another function here, another comment. So if we give it the Fibonacci number of, let's say, what was it? Let's do 5. Let's do 5, I think. 5 is a good number. So if I give it the number 5, it's going to take Fibonacci of 5. Oops, gotta put this in comments. Fibonacci of 5. Then we're gonna say, is number less than 1? No, right? Our number isn't less than 1. It's going to be, is it less than 1? Return none. We don't do that one, right? Then if number is less than 3, we return 1, right? Not less, 5 is not less than 3. So now I'm going to put a tab here, right? We still keep our Fibonacci of 5 is still going to exist, but because it doesn't do these two, it's going to go here. Fibonacci number minus 1 plus Fibonacci number minus 2. So now it's going to be fib of 4 minus 1. You know what? I'm changing my mind. Oh man. Okay, 5 is going to be a lot of showing. Plus Fibonacci. Oh, not 4. It's going to be 5 minus 1, right? And Fibonacci of 5 minus 2, because that's what it is here, right? So now what's going to happen is it's going to evaluate this one. It's going to say, let's do 4 instead. I'm going to do 4. Sorry. Too much extra work. That's going to be a lot of writing. This can get a lot really large. This is why this is inefficient, but it gets really large. So Fibonacci of 4 minus 2, right? So we're going to have Fibonacci of 4 minus 1, which is going to be 3, and Fibonacci of 4 minus 2, which is 2, right? And then the 4 again, it's not less than 1 and it's not less than 3. Now what's going to happen is that this right here is going to get evaluated next. So fib 4 minus 1 is going to be evaluated first, and this is going to return is 3. This is 3, right? This is going to be 3. So this points to this. So Fibonacci 3, right? Is 3 less than 1? No. Is 3 less than 3? Also no. So here we're going to have to do it again, which is going to be fib of 3 minus 1 plus fib of 3 minus 2. Then we're going to go down and do this one. As you're noticing, we're leaving some stuff behind, right? We're going to get back to that. So here we're going to do fib of 2. 3 minus 1 is 2. I'll keep the 3 minus 1 there just to clarify it. So here now we have fib of 2. So what's going to happen is 2 less than 1? Nope. But is 2 less than 3? This time, yes, it's return 1. So here we're going to return, we'll say return 1. So then we're going to say that this is going to equal 1, right? Or let's put this at the end of it, which is going to be another comment, which is going to be 1 plus, but now it's going to do Fibonacci of 3 minus 2, right? It's kind of this tree we're kind of creating. This is kind of a tree that they in future computer science programs, they'll call it a tree, and you'll see it why later on, but it'll look like a tree. So Fibonacci 3 minus 2 is going to be fib of 1, right? So now let's go back here. Fib of 3 minus 2, because we have to finish this off, is going to equal, we'll put this here, 3 minus 2 is 1. So if number is less than 1, we return nothing. Well, the good thing is 3 minus 2 is going to be 1, right? Or is 1 less, 3 minus 2 is 1. Is 1 less than 1? Nope, right? Is 1 less than 3? True. So now we're going to return 1. So 1 plus 1 equals 2. So now this equation for fib 4 minus 1 gets returned as 2. So this value right here equals 2. And then now we have to go and do this equation, right? We came back to where we started. Fib of 4 minus 2, and that's going to equal fib of 4 minus 2, which is going to be 2, right? So 2 less than 3, we're going to return 1 again, because 2 is not less than 1, and 2 is less than 3, so we return 1. So now this is going to equal 1. And so our final answer is going to be 2 plus 1, which is going to be, I'll put another comment here, 2 plus 1 equals 3. If you look at this, 1, 2, 3, 4. Fibonacci of 4 equals 3. That took way longer than it should have, but we did this in a recursive manner. That's the whole point of this. So if I run this with run, unless I counted zeros, oop, I have to save this. Let's go and save this. You guys can see all my demos. Save as, say recursion. Oh, what happened? Nothing ran. Can anyone tell me what just happened? I just ran it. I didn't even get the number 3. Didn't get anything. Anyone have any idea as to what just happened?
Num doesn't have any value right now.
Num doesn't have a value. Okay. So how would I give it a value?
Input.
Input, or we call it, right? If we don't call it, it's never going to work, right? This is kind of the whole point I was trying to get to was, if we defined it, we defined it, right? But now, in order for it to actually work, we have to call it, which is why we give it the input of num is, in this case, we want 4. So we give it fib of 4, and then fib is short for Fibonacci, fib of 4, and now I'm going to do that, and then let's run it. Huh. I called it. Crystal, do you have any idea what's going on? Why am I not getting an answer here?
I don't know, I'm looking.
Anyone else have an idea? Sebastian, Mario, Dogfin? These are the only ones in the class, actually, so it's just us.
There's no print.
There's no print statement, right? Either I say x equals fib of 4, print x, or I say print fib of 4, right? You have to, we're not getting any output because we didn't put any print statements. Simple fix. I'm gonna do I like doing this answer. Let's do ans equals fib 4. This looks a little bit cleaner in my opinion. It's an extra line, but I like it. So print ans. So here I'm going to run it. And now, oops, I put a 0 instead of a end parentheses. Stupid shift. Okay, shift now works. And now I can push 3, right? So we got the answer we wanted. 2 plus 1 equals 3. That's how you will trace your, and that's exactly how code tracing is, or code debugging. I just went through and manually did the math of what my whole function does. But this is how it is recursion, right? I called Fibonacci by itself, and I kept using these base cases, right? And the base case is that anytime we hit an area where it's if num is less than 1, we return none, or if num is less than 3, we return 1. Those were our 2 base cases. If it ever hit 0, 1, or 2, we would return something. If it wasn't 0, 1, or 2, we keep going and breaking it down. So the idea is, and you can see how bad this would have, the reason why I changed from 5 to 4 is that this was already a lot of work. 5 would have been a lot more work of going through the function, and that's why it gets inefficient. And I'll show you something pretty cool. I actually posted a video a long time ago. If anyone is interested, I made like a 5-minute video. It's only 5 minutes for my TA job that I do right now at UCSD, of a better way of doing Fibonacci sequence. And the reason why there's a better way of doing Fibonacci sequence, again, recursion, it may seem like not good, but recursion is very useful. There are uses for it later on and more advanced techniques, but you will find a time where it is useful. But in recursion of Fibonacci's numbers, you see how heavy I got. I didn't want to do it for 5 because I was like, this is going to get big. If I did it for, let's do it for 30. Let's see what happens. Actually, let's do 20 first. Let's run it for 20. That was really fast, right? We found 6,000. That was super fast. So our computer is smart enough to get that done really fast. Oops, I ran it again. Now let's make it 30. Let's see what happens. It was a little almost just as fast. I think there was a little bit of lag time with it. Now, if I run it with, oops, I gotta keep changing the number. Let's do it with 40. It's taking a while. I think I just stumped Python, right? Let me cut, I'm going to end it actually. And I think there's a sweet number too. I think it's 36. And the reason why 40 took so long, and it will take a while actually to do it, and it is taking a while for this, this one was able, this was the sweet number. It took a little bit of time, but I was able to get it. The reason why, oh, you've done this by hand for fun? Oh my goodness. The reason why 40 is a terrible number is that, I'll give you guys a quick fun tribute. This is, again, if you want to watch my video, feel free to ask me and I'll post it in the Netacad thing. But Fibonacci of 40 is going to take a trillion operations. So that means this math that we just did for Fibonacci 4 minus 1, for the number 40, it will go through this, it will go through it a trillion. You will do a trillion operations, a trillion calls to Fibonacci, which is why it takes forever. In some cases, you won't actually reach it. Your computer, your program will just crash. It'll be like, I can't get to 40. So there are better ways. You can always do a recursive function iteratively. And iteratively just means without calling itself. What we've been doing before is iterative. But this would be a recursive is when it calls itself at any point with a base case to satisfy it. So I think that's a pretty fun one. And again, if you guys have any more excitement for it, feel free to email me and I'll send you the file. It's only a 5-minute video I created of it explaining what's happening or explaining a better way to go and do it. It's a better way, really, more advanced too, but cool stuff. And then again, any other recursion we could do another one. This one is going to be a little bit less. Let's do define fun fact, and this is going to be if n is less than or equal to 1, return 1, return n times fun fact n minus 1. And let's run this. Oops. What's wrong with return? Ooh, I was like, I was wondering what I was doing wrong. I misspelled return. Oh, it's still doing this, right? Okay, well, let's comment this out. Control 3, I believe. Yep. Okay, perfect. Let's run it now. So now we're not going to call Fibonacci, right? We're not going to call it because there's no call to Fibonacci. So we don't have to worry about our computer getting slow. No output again. What happened now? Anyone with an answer? Why am I not getting an output now?
We didn't call the function again, nor did we print it.
Exactly. Exact same thing as last time. And I'm going to say answer 2, because the first one was answer 1. Answer 2 equals to fun fact of, and let's say 5. And let's say print ans 2. Oops, run module. Okay, perfect. So now we got 120. Okay. Okay, let's see what did we just do? Did anyone notice what just happened? So let's run this together. Let's tell me what's going on, I guess, this way, right? We're gonna say we're doing it for 5, right? So let's put some stuff in here. Fun fact of 5 is going to equal, and this is recursive again, right? Is 5 less than or equal to 1? No. We're gonna return it's going to, let's tab it again, return n times fun fact, n is going to be 5, times fun fact of 5 minus 1. Man, I'm really bad at pushing shift. Minus 1. Then we're going to have fun fact, which is going to become, right, fun fact of 4, right? What's fun fact of 4? Is 4 less than or equal to 1? Return 1. Nope, it's not less than 1. So let's return 4 times that. 4 times fun fact of 4 minus 1. And then we're going to do fun fact of, or it's going to be 3, right? Because it's going to be if 3 is less than or equal to 1. No? Times fun fact of 3 minus 1. What am I doing? Someone should pick up on what just happened. I haven't finished it yet, but something's going on. The answer also is in the name. It's almost given to you. What is my code doing? What is this function doing? Just as a hint, the answer to what I'm asking is what is this function doing is also in the name of the function we're currently in. I'll go ahead and finish this off. I'll say 2 times fun fact, right? Because we know 2 isn't less than or equal to 1. 2 minus 1. Now we're going to have fun fact of 1, return 1. 1. That's it. So now this 1 is going to go here, and then this number is going to go into here, and then this number. So we can walk through this together. This is going to equal 2 times 1. Anyone have an answer to this at any point? Times 2 times 1. I'm about to give you the answer as open as day. 3 times 2 times 1. And this is going to equal 5 times 4 times. What is this doing now? Someone should give me an answer at this point.
Factorial operation.
Factorial operation, right? Exactly. So all we did, and then the fact was the factorial. So all this was doing was it's going from 5, timesing it by one number less, then 4, times it by one number less, 3, times 2 times one number less, times 1 times number less. And then once we hit 1, we said we're not going to count 0 because if we obviously, and I can show it to you, let's say n is less than 1. If n is less than 1, return n. So if n ever gets below 1, return n. What's the answer going to be? I want someone to give me an answer for this. I just changed the operation. Will this change anything? I've given you, what does this code change where I said if n is less than 1, return n gonna do? Anyone? We have 5 times 4 times 3 times 2, and then let's say we're gonna get to 1, right? Crystal, I'll go and call on you. Once I get to 5, let's say we start from 5 again, we get 5, 4, 3, 2, and we get all the way down to 1. If 1 is less than 1, is 1 less than 1?
No.
No, right? So we're going to return 1 times what? What are we going to return now? It's going to be 1 times, and then what's this doing? Oops. This is just going to call this function again, right? We're just going to go back to here.
Okay.
Right? What's going to be n minus 1? Because right now our n is 1. What's 1 minus 1?
0.
0, right? So we're going to say 1 times fun fact of n minus 1 is 0. So then we're going to get all the way back to here. Now our n is going to be 0 now. What is this going to do? Is n less than 1?
Yes.
Right? It's going to so then what's return n going to do? What number are we returning? What is n going to be when I push return? We just said 0 is less than 1, or n is 0. Return what?
0.
0, right? We're gonna return 0. So now we're gonna get back to here. So now we're gonna have 1. So the idea, you know how I just showed you, right? We go back all the way back up, right? 1, then 2, then 3, then 4, then 5. And then we keep all these things right now. This is gonna be 1 times, and we just return, what number do we just return? The number
0.
we just, yeah, 0, right? We just returned 0. So what's 1 times 0 gonna be?
0.
0. So if I keep applying this number, right? So let's say we're gonna go down here now. We just added 1 extra step of 1 minus 1, which is going to equal what? What is this gonna answer equal to? It's gonna equal 1 times
0.
0. So then what's gonna happen to all these things?
They're all gonna equal 0.
They're gonna all equal 0. So when I run it, what do you think our final answer is gonna say?
0.
0, right? So just because I messed around with my base case, I got all of them to equal 0. And if I return back to what we wanted, which was if n is less than or equal to 1, return n. So meaning that if it never hits 0, it goes and does the math without the zeros. So I just wanted to show you guys what happens if you mess around or get your base case wrong. Hopefully that helped a little bit with it. And so then that's pretty much all I have with that. We went over the scopes. In the last 15 minutes of class, let's go over, does anybody have any questions or anything you guys want to go over in specific? If not, I'm going to go over just a little bit more advanced stuff or the next week stuff. Does anyone have any ideas, anything going on? And then also, if you want any more help with it, creating functions, Fibonacci numbers, creating functions, factorials. Wait, did they actually do this beforehand? Huh. They actually do. That's funny. Usually they do factorials first. Uh-oh, spaghetti-o. Just wondering, can you guys all hear me?
Yeah.
Okay, perfect. I've been having problems with my internet, and it's really strange because some things will work and some things won't work. So right now the Zoom is working, but this Python Metacat isn't working. Now it is. Okay. So here, this was the creating simple functions. Again, this is actually a fast module. Module 3 was probably the biggest module you guys had. Module 4 is literally just taking all the stuff you did in module 3 and saying, put it in a function so that you just define it. And if you ever want to call it, you just call it here. It's really just like, you're just, instead of calling it automatically, it's just I guess functions are just a better way of organizing your code. That's all it is. So, if you look at, if you're like at any point daunted by functions and all this stuff and scopes, it's really just a way to organize your code better. And I mean, it's a must thing you must do when you're writing code, because code organization is so important. Because if you write, let's say if you give me like 5,000 lines of code and there's no functions, I'm going to be like, what are they writing? I can't go line by line to figure out what's going on. But if you create a function that says, oh, this chunk of code is for calculating the sum, this chunk of code is for calculating, let's say, the average, even though you could probably do those in both. Or like, let's say you're creating a YouTube web page, right? Let's say you're creating YouTube in general, right? This function creates the website. This function is for creating the video. This function is for putting the video on the website. And this function is for the users, right? If you don't put any of those in their functions, you're going to have a whole bunch of code that no one's going to know, because YouTube's code is probably humongous amounts of code in it. But if you have it in functions, you can break it up into smaller pieces, and it's way simpler. So that's why it's so important to have functions. But again, it's just a way of organizing your code. So don't be too daunted by it. It's just what we did in the past, but we're just putting it in a nice little space just for itself. Creating simple functions, we have testing triangles, 3-parameter functions. So as before, we were running it with 1 argument. If you can create multiple arguments, n, x, m, whatever, you can create arguments with as many parameters as you want. The world is yours on that. If you want to calculate sum and total, you can do all this. Or would you go for predefined functions and the community has created and can repurpose? Where would you go for predefined functions the community has created and can repurpose?
So,
So-
okay, can you
Yeah,
hear
go
me?
ahead. Yeah.
So if you're writing a program and you want to save time, wouldn't it make sense just to see what's out there, just to give you ideas? And then the question is, where would you go just to give you ideas what's out there to save you time to doing anything, basically?
So I would say for that is that like usually that's more advanced stuff, but everything you're doing in this class can be found on Google, on what is it called? Stack Overflow. They're not good for you guys just yet because you guys are very young in programming. You want to learn how to write these simple functions. But when you start doing advanced things, for instance, predefined functions. Whenever you want to go for predefined functions, you don't actually want to copy and paste their functions in your code. It's kind of like that list append thing we had, right? Where it's like, or input. We're not going to go and write out the function of, so let's say input hello, right? We're going to say that, and then let's say x equals input hello, and then print x, right? So we're going to print x. I just used two functions that are given to input hello. I'm so silly. It's not what you're supposed to do. Input hello, your name. Let me go change this. Refresh that. I made a mistake. Your, oh my goodness, this thing's your name. All right. Print X. So here I'm going to say hello. Okay, and then let's say K for my name. K, right? Print. So we have two things here. We have input and print. These are functions that were given to us through Python. So in this case, this input function is already predefined. I'm not going to go here and say def input, right? I could, but this is something that Python has created for me. So there's no point in doing that. There's going to be other things you do in your later in life, like this. If you want to do machine learning, right? They'll say, apply this function. Like let's say machine learning function, def machine learning function, right? We can create a whole bunch of lines that says what to do here. Or we can go online or through Python's library, they call it. I think Python has a library somewhere. Python's library where they give us functions. A popular one for this is called scikit, I believe. This is Python's, all their machine learning functions are there. So we don't actually have to define them. We just can call them. So hopefully that kind of answers your question, Mario, but like there are areas for predefined functions, but usually they're under a package or a library, and then you can steal their code and just, you don't get to steal their code, but you can use their functions like this, inputs, right? We didn't define input, print we didn't define, but Python defined it for us, and we're just taking their code and just applying it to our own. Does that make any sense, Mario? Or does that hope that answers your
No, it
question?
does. And
Awesome.
it does. And one of the things, for example, is like I know that there's user-defined functions like in GitHub, I believe.
Mhm.
I'm not familiar enough, but I was just trying to see your input. If you have any recommendations, I don't know enough of where to go. I've heard of GitHub, but if there's any other places that you recommend.
GitHub is one place where it's where there's a lot of open source code. That's a good spot to, if you want to go and get code from other places, predefined functions. But usually those GitHub function, it's not, you won't find places to find predefined functions. It will just be like Google. You can just Google up, hey, can you give me a function that does Fibonacci? That Fibonacci function that I just wrote, you can find a billion probably different alterations of this same function. You just Google it. That's the best way to do it for those type of functions. But in terms of GitHub's going to give you a whole program. Like it's going to give you the whole how to create YouTube, which might be a little bit too much for you. So I would say Google is your best friend. But other than that, yeah, I hope that's a good answer for that. And let me get back to learning about, but that's a good question though. Great question. If you have any more questions like that, Mario, feel free to email me, or any of you guys, if you have any questions. I am free for email and free for having meetings. I would love to meet you guys or have one-on-ones with you guys, really. And then in the last 10 minutes of class, we'll go over this tuples. This is what we're gonna go over next week in week 10, and then week 11, we're gonna go over your dictionaries, and then week 12, we're gonna go over exceptions. Those are kind of like the most advanced stuff in this class, but shouldn't blow your mind, I think. So here we have a tuple. A tuple is tuple 1, 1, 2, 4, and 8. It's a thing you use with parentheses, not with brackets. Brackets was the list we would create, or an array, or whatever it may be. Tuples are used with parentheses. And the main important thing to know the difference between the two, and they talk about it this way as well. Even though a tuple is very similar to a list, it's immutable. And immutable is a very key word that I want you guys to know, which is immutable just means you can't change it. If it's mutable, you can change it. Oh, you're on fast forward. So there are two kinds of Python data, mutable and immutable. I know I'm going a little bit fast right now. The time is going, I have 8 minutes left and I want to go over more stuff with you guys. I have such a fun time, even though it's only an hour long we get. The second notion is mutable. Second, I'm just reading what they're saying. So mutability is a readiness to be freely changed during program execution. That's their long and lengthy answer to mutability. All you need to know is if it's mutable, you can change it. If it's immutable, you can't change it. You can't change the data of it. But there are ways that you kind of go around it, right? So if I want to do append with a tuple, it won't work. Oh, what's going on? All right, sweet. My internet's so bad. My tuple 110, 100, 1,000. And again, we're using parentheses. So it works exactly like a list, right? We have the 0, the -1, the 1 colon, the -2. And if I print it, we're going to get the 0 element, which is going to equal 1, right? The -1 element, remember that's the reverse. The reverse is going to be 1,000, right? -1, -2, -3, -4. And then 0 again going forward. Print my tuple 1 colon, which is going to give us 10, 100, 1,000, 10, 100, 1,000. And then my tuple of -2, which would mean -1, -2, 100. And we're going to get 1 and 10 because it just prints up to this point. Because -1, I mean, -2, as I just said. So we print up to -2, we're only going to print these numbers. And then for element in my tuple, we print elements, right? Works exactly like how a list works. But if we want to do something like this, my tuple.append, just like how we did with list. Oops, let me just refresh it. This is, Etiquette is not nice with their console. Okay, as you can see here, you can see we crashed the code. Don't pay attention to this part as much, but we crashed the code because my tuple append 1,000 or 10,000, whatever it is, because it's not a list, it's immutable. Immutable means it can't be changed, thus meaning you can't append it. You can't delete it because that's a list item, so you can't delete something. And you can't change the value like this. So any of these, if you want to do one by one, we'll do that one. And if I see it crashes again on here, can't delete it. And if I try to change the value at a certain area, you can't because that's legal. You're changing the value. So immutable. Type object has no attribute append. In this case, does not support item assignment. So it's illegal to change it. But a tuple, really the use of it is just that it's, and then we go to dictionary, it's that fast. So that's why I'm kind of speeding through this, is because the book doesn't really, it talks about it very little. All it is just something that you can't change. It has its uses, right? For instance, if you want to make it where your user can't change the value of something, you just make it a tuple, right? Although you want it to be a list, then the value can change it. Usually tuples aren't used as much, but tuples and dictionaries in conjunction are pretty useful. Dictionaries are useful as well. We'll get into that next week. It's a very cool thing what dictionaries do. It just stores things for you. And I'll say this is probably your first, the things you were learning about in the past three, like the first 3 modules were introductions and basics that you need to know when learning how to code. This is more advanced stuff we're getting into with tuples and dictionaries. But even though I say advanced, it's fairly simple. It's just that these have pretty good implications for what you could be using. Like if you wanted to make a database, right? This is a good way of doing it in tuples and dictionary. And I'll show you a quick thing. Dictionary. I can say cat, chat, dog, boss, phone numbers. I can make a dictionary where I have a boss and then his phone numbers and then Susie with that. And you can kind of do that in conjunction with tuples, which is why we're just going to stick with tuples for right now. Next week will probably be both tuples and dictionary, because tuples, they don't actually go very much into detail of it, and there isn't much in it, but it had the main point that you want to know from tuples is it works exactly like a list, except there's things that you can't use with it like a list. It's immutable. Anything that involves changing the value will be illegal, but anything that involves you know, the ins, the not in, to print it out, still the same. And then to print out different versions of the list, still the same. It's just going to be immutable. You can't change any variable. You can't change any value of it. So this my tuple can't get changed. But this my tuple plus 1,000 plus 10,000, I can change T1. I can add it, right? I can add another tuple and combine it. But I'm not changing any values here because it's my tuple plus that. Now let's see, I'm kind of curious. If I just try to reassign it, will it work? Should work, I believe. Okay, I should just. Or crash, I don't know. I think my internet just crashed. Okay, it actually, oh, print T1, it does not like that. Let's go and do that. Okay. Let's refresh it because it doesn't like it. Sweet, it works. So we can redefine a variable name. You can always do that, right? But if I wanted to just say my tuple plus 1,000 and hope to change that value, wrong. This would be creating this in this way. This kind of gives you an idea of what Python does. You're creating a new variable called my tuple and kind of reassigning it with this variable of my tuple. You're reassigning it. You're not changing the values. But if we go back to making this T1, you can make it where you have 110, oops, 110, 1,000. You can add it to make it like that. You can print the length of it. That's still legal. Of my tuple times 3, and my tuple times 3 kind of works exactly like a string again, where I can just take this tuple 110, 100 right here and do it 3 different times, 110, 100, 110, 100. And it is 359, and I think I kind of went over it a little bit. And then you can still do the in my tuple. Is 10 exist here? Is -10 not in my tuple? That is true, right? But if I did 10 not in my tuple, it should become false, right? Because 10 is in the tuple, so we get false. Other than that, we are done for the day. I hope you guys had a fun 3 to 4 session with me. Oh, let me stop the share. Oh, stop the share and let me stop the recording.